C also supports lists. So if you have, for example, input output, of course, and the main function, which is always the start of a C program, we can have a list of numbers, for example, 1, 2, 3, 4, 5, 6, or perhaps certain years. So let's say 1991, 1995, 2001, 2005, 2009. So you can have a certain list, and you can store that into a single variable, a list variable, which in C is called an array. So array is just a synonym for list. So you can say int years, and then C needs to know how many, because C is very low level, so it needs to know the size of the list. In this case, we have 5 numbers, so we can say, okay, let's store it into 10 numbers. We have some extra space, and a list is defined like this. So this defines a list of numbers, which is of a maximum of 10 numbers. If you have more, C will just crash. So if you run this code, you see it runs and it doesn't output nothing. But if we were to put like too many, more than 10, C would crash or say do something you wouldn't expect. So now it's a lot larger than 10, and if you run it, then okay, in this case C doesn't crash, but it overwrites the data. So that's not what you want. So we can output any value in the list years. So printf, it's an integer, right? These are all integer values. Let's say integer years, and then the index. Now C starts counting from 0, so you can say 0, and it would output the first year. So 1991 is the first item, so 0 is the first item in the list. If you want a second item, you say 1. 1 is the second item. Of course, computers start counting from 0. Humans might sometimes start counting from 1. At least before they discovered the number 0. Computers always start counting from 0. So 0 is the first item, 1 is the second item, 2 is the third item, and so on. So you'll see 2, it will output the third item because it starts counting from 0. So if you run it, you'll see outputs 2001, which is the third item. So 2 references the third item in C. If you want, you can use a loop instead of doing that individually. So remember, a loop for the start, the end, and the increase of 1. Now the start for the index variable starts at 0, smaller than smaller or equal to 5, and then because there's 5 items in the list, and we can say output I is I. Sorry, years, we need to output the list. So years, and this indicates the item in the list. So if you run it, you'll see that now it loops over the list items. So you'll see it repeats that code, and every list item it runs that line of code. That's why it outputs, and you'll see that it goes further than the list size because it starts counting from 0. So actually we want it smaller than 5. Now it outputs every list item of this list. Now a list doesn't have to be just numbers. So what you can have also is a list of characters. So you can have a list of characters. So in the same way, we define some characters, let's say name or letters. Let's say the size is, maybe we want a maximum of 10 characters. And, sorry. So this defines a list. And here we do the same, define list. And this shows a list. And of course, we can do that again. So we can say show list. We just copy the code. And instead of years, we show letters, the letters list. And instead of numbers, oh, these are not letters, sorry. So those are characters. Instead of numbers, we show characters. So instead of I, we need C for characters. And you'll see when we run it, it starts looping over the character list. Now, just remove that. And you'll see it loops over the character list now. We can be a bit more explicit and say letters, then output the number is C. So now it outputs the index as well of the letters list. So if you run it, you'll see it outputs the index and the value. We can do the same thing for the years list. So we can say years, I is I. So if you run it, you'll see it outputs the list and the index with the value. And it does so for the other list as well. So that's lists. And you'll note that lists can also be used to define a certain text. So when you have a text, for example, we define a list. We have a text, for example, greeting. We don't know exactly how large, so you can do it like that. And then put some text. And it's a list, so you can output it also like this. So we want to show this list of greeting. It's a list of characters. So C is really low level. There is no word or sentence per data type. It's just a list of characters. And the list is always indicated by those braces. So we want to show that. So greeting and reference greeting. So now if you run it, you'll see it outputs the greeting. Now with text, you almost never output it like this, right? So what you can do instead is remove all that, remove the new line, and you'll see now it outputs the text. But it only does 5 characters here, so you need to know that it's more than 5 characters. So let's say we output 20 characters. And you'll see it outputs more than 20 characters. So we have our text here, which is the text. But it also, C is like really low level. So when you want 20 characters from the memory, it gives you 20 characters from the memory. And that's why you see a bunch of nonsense there. So C needs to know the exact size of the text. Otherwise, it just continues writing the characters from the memory, in which case there is no characters from the memory, right? So then it writes a bunch of nonsense. So add a new line, and you'll see now we made our own text output function. You'll see it outputs hello or whatever we put there. Now the printf function, luckily it can just output text. So we can remove all that and say printf text, so %s, new line, and output greeting. And then when you run it, you'll see it just outputs the text.